Students, today we are going to see part 3 of the first chapter, that is measurement. The contents that we are going to see today are measurement, physical quantities and its types, units and its types, measuring systems, fundamental quantities, derived quantities and methods of measurement. First, let us see what is measurement. Measurement is actually the comparison which has been adopted to represent a physical quantity in terms of its standard unit, the basis on which all other scientific studies were found to depend. And measurement is found to play an important role in our day-to-day life. We get up in the morning based on certain time, then we go to school by following a certain path, and in doing so, we try to cover certain distance. Then your mother goes to the shop, she buys the groceries based on certain weights. So like this, we can cite many examples for measurement. So when we talk of measurement, we should know what are the physical quantities involved. So physical quantities are those quantities which can be measured, and based on these physical quantities, all other laws of physics are found to be described. And these physical quantities can be of various types, for example, length, mass, time, etc. Now we can classify physical quantity into fundamental and derived quantities. Fundamental quantities are those quantities which cannot be expressed in terms of any other physical quantities. For example, length, mass, time. And the derived quantities are those which can be expressed in terms of the other physical quantities. For example, area, velocity, force, and so on. Next, we'll see what is meant by units and what are its types. So units, by definition, it is given as the arbitrarily chosen standard of measurement of a quantity which is accepted internationally. That means these units have been randomly chosen, but now they have been accepted internationally and is being followed all over the world. And these units can be of two types. One is fundamental unit, the other one is derived unit. Fundamental units are the ones which are used to represent the fundamental physical quantities. So the unit in which the fundamental quantities are measured are called as the fundamental units. Likewise, the unit which is used to express the derived quantity is called as the derived units. Of units, one is the FPS system, the CGS system, and the MKS system. The FPS system is the British engineering system of units, in which length has the unit in foot, pound is the unit of mass, and second is the unit of time. In CGS system, that is the Gaussian system, the unit of length is given in centimeter, gram is the unit of mass, and second is the unit of time. In MK system, that is the metric system, the unit of length is given in meter, unit of mass is in kilogram, and unit of time is in second. Now students, you can notice that in all these three systems, the unit of time, that is second, is found to be the same. Now let us see what is meant by SI unit. So SI unit is an international system of unit which is being followed all over the world, and it has been actually developed and recommended by the General Conference on Weights and Measures in the year 1971. And this is found to have, that is the SI system of unit is found to have certain advantages. That is, it is considered to be a rational system of units. That means only one unit is used to represent a given physical quantity. Like for example, for force, the unit is Newton. Then it's found to be a coherent system of units. That is, the derived units can be got with the help of the fundamental and the supplementary units. For example, acceleration has the unit as meter s power minus 2, where the acceleration by definition is given by distance divided by time squared. So it is meter by second squared, from which we got the unit of acceleration as meter s power minus 2. Then in the SI system of unit, the bigger values or the very small values can be expressed in terms of the powers of 10. So as a result, the SI system is found to be more advantageous compared to the other system of units. Let us now see the 7 fundamental quantities and their units. That is, first one is length, whose unit is meter and its symbol is small m. Mass has the unit kilogram, which is represented by kg. Time has the unit second, which is represented by S. Electric current has the unit ampere, which is a scientist name, so its symbol is capital A. Temperature has the unit Kelvin, which again is a scientist name, so this is represented by capital K. Amount of substance is given in mole, its symbol is MOL. Then luminous intensity is represented by candela, whose symbol is CD. Let us consider light traveling in vacuum with a speed of 3 into 10 to the power of 8 meter per second. We find the time from which it has started to move, that is t is equal to 0, till it reaches a time of t is equal to 1 divided by 299,792,458 seconds. That is a very less fraction of a second. So from t equal to 0 till it reaches this fraction of a second, we are calculating what is the distance traveled, and this distance is called as 1 meter. So 1 meter is defined as the length of the path traveled by light in vacuum in 1 by 299,792,458 of a second. Next, let us see what is 1 kilogram. For this, a cylinder has been considered which has been designed based on the international prototype, and this cylinder is being made up of platinum and iridium alloy and is kept at the International Bureau of Weights and Measures near Paris. Now the mass weighed by this cylinder is called as 1 kilogram. So 1 kilogram is equal to the mass of the international prototype of a kilogram, which is made from platinum iridium alloy cylinder and is kept at the International Bureau of Weights and Measures at Suez near Paris. Next is 1 second. Now for defining 1 second, we consider cesium-133 atom, and at the ground level for cesium-133 atom, in between two states, that is between n is equal to 4 to say n is equal to 5, we find out the number of transitions made between the hyperfine lines. And in doing so, the time taken for 9192631,770 Hertz, that is, time taken for this many waves to travel is noted, and this is found to be equal to 1 second. So 1 second is defined as the time taken for 9192631,770 period of radiation corresponding to the transition between the hyperfine lines of ground state of cesium-133 atom. Now let us see what is meant by 1 ampere. Say we are having two parallel straight conductors whose length is not defined, so they are of infinite length. They are placed in vacuum and they are separated by a distance of 1 meter. Under such situation, they experience a force of 2 into 10 to the power of minus 7 Newton per meter length. Now, the current that is passing through them is called as 1 ampere. So the ampere is defined as the constant current which, if maintained in two parallel conductors of infinite length of negligible cross-section and placed 1 meter apart in a vacuum, would produce between these conductors a force of 2 into 10 to the power of minus 7 Newton per meter length of the rod. The next we are going to see what is 1 Kelvin. Before that, we should know what is meant by triple point of water. This is the temperature at which water exists in all the three states, that is in the solid, liquid and the gaseous state. And for water, the triple point is found to be 273.16 Kelvin. Now 1 Kelvin is defined as the fraction of this thermodynamic temperature of triple point of water. What is 1 mole? Suppose we are having 1 gram of pure carbon, that is C12. In 1 gram of C12, the number of atoms present is noted. Now, in order to produce the same number of atoms by some other substance, the amount of that substance needed is called as 1 mole. So I hope you can understand. That is, 1 mole means the amount of a certain substance that is taken so that it produces the same number of atoms as the number of atoms present in 1 gram of C12 atom. Next, let us see what is 1 candela. Candela is the unit of luminous intensity, and for this we need to consider a source of light, and from the source the amount of radiation that comes out with a frequency of 5.4 into 10 to the power of 14 Hertz is noted. Now the intensity produced by this frequency is called as 1 candela. So 1 candela is the luminous intensity in a given direction of a source that monochromatic radiation of frequency 5.4 into 10 to the power of 14 Hertz, and that has a radiant intensity of 1 by 683 watt per steradian in that direction. Now let us now see the derived quantities and their units. Only few examples I have cited. Let us consider area. Area is represented as length into length, whose unit will be meter into meter, or in short we can represent it as meter squared. Then surface tension has the unit force per length, whose unit will be Newton by meter, which is represented as N by M. Power has the unit, power is represented by work done by time taken or rate of doing work as Newton meter by second, or Nm s to the power of -1. The next is density, which is equal to mass per unit volume, which has the unit as kilogram by meter cubed, or kg m per -3. Let us now see what is meant by length. Length means it is the distance between any 2 points in space. For example, if we have 2 points A and B which are separated by a distance of 8 centimeter, then we can say the length between them is equal to 8 centimeter. Now this distance can be calculated either at a larger level, that is at the macrocosm level, at the macrocosm level, which involves the study of the distant stars, or at the microcosm level, which involves the study of atoms. For measuring the distance, we can either adopt a direct method or an indirect method. For direct method, the range should be within, say, about 10 to the power -5 meter to 10 to the power of 2 meter. And most conveniently, we use the meter scale to measure distances between 10 to the power -3 meter to 1 meter. For example, if you need to find the thickness of a thread, we wind it closely around the meter scale. Then the length of the turns is calculated as L. Number of turns calculated is small n. Now the thickness of the thread will be given by the formula L divided by N. So this is a simple way and convenient way of calculating the thickness of the thread. There are more accurate devices to calculate the length of an object. Say for example, if you have the Vernier Calipers, you can use it to measure the distances up to 10 to the power -4 meter. And the Vernier Caliper A screw gauge is said to have more resolution compared to the Vernier calipers, that is about 0.01 millimeter, and screw gauges can be used to measure distances or the length up to 10 to the power of minus 5 meter. Now, till now, we have seen about the direct methods that have been involved in calculating the distances and the length of the object. Now, we go to the indirect methods, which are used to calculate either very small objects or very large objects. First among this is the optical microscope, which uses visible light, and its resolution is almost equal to the wavelength of light used, which can range from about 4000 angstrom degrees, that corresponds to the wavelength of violet color, to 7000 angstrom degrees, which corresponds to the red color. Smaller objects can be also measured with the help of the electron microscope, in which electron beam is used to focus on the object with the help of the electric and the magnetic field. And this electron microscope is found to have a resolution of about 0.6 angstrom degrees, and this can be used to study the atoms and the molecules in a material. Next comes the tunneling microscope, which has still better resolution compared to the electron microscope. And using the tunneling microscope, we can estimate the size of the molecules. Now, till now, we have seen how to measure the very small distances. Now, we'll see how to measure the larger distance. And first method used is the triangulation method. By this method, we can determine the height of accessible objects. For example, if you need to find the height of the tree, we follow this particular method. So let us consider the height of the tree as h, and the point from which it has been observed to the base of the tree is taken as x. Let ACB be equal to theta. From this figure, we can see tan theta is equal to AB divided by BC, or you can write this as h divided by x, from which the height is given by the formula x into tan theta. The next method that we are going to see is the parallax method, and this method is usually used to find very large distances, say for example the distance of a distant planet. Now for this, we should first understand what is meant by parallax. Suppose we need to view an object. Keep one eye closed, say the left eye closed, and see the object, and its position is now noted as say R. Now the right eye is closed and the position of the object is again noted. It is found to be at L. So there has been a shift in the position, and this shift in the position is called as the parallax. And the angle subtended at the center is called as the parallax angle, which is represented by theta. So angle LOR is equal to theta. Now this distance between the two observations, that is LR, is given as the basis B. So now we can say theta is equal to B divided by x, where x represents the unknown distance.